Okay, let's compute the sample standard deviation. We'll start by computing the sample mean. X bar is equal to the sum of the individual x's divided by the sample size, or 30 divided by 6 is equal to 5 in this case. To calculate the sample standard deviation, we'll start by getting the deviations of each value from the mean, or the difference between each value and the mean. We'll call that a deviation in statistics. So anyway, 3 minus 5 is minus 2. 8 minus 5 is 3. And that will always sum to be 0. That's the sum of the deviations is always equal to 0. Which, if we want to get something that's sort of the average distance from the mean, we'll have to find some way to make all of these deviations positive. And the way that works out best for many applications in the field of statistics is to square those deviations. So the minus 2 squared is 4, and so on. And that all adds up to 22. So the standard deviation, the sample standard deviation, is equal to the square root of the sum of the x by minus x bar squared. That's this 22 down here, and it's sometimes referred to as sum of squares total, divided by n minus 1. And n minus 1 is something called degrees of freedom, or df. For now, just think of it as it is n minus 1. And we'll talk about degrees of freedom a bit more later in the semester. There were 6 numbers there. And so 6 minus 1 is 5. And then we will come up with an answer of 2.10 for the sample standard deviation. While I'm here, I'll also say if we were calculating the sample variance, we would follow everything just as it is here, except for we would have s squared, and we wouldn't have the square root sign. So it would just be s squared is equal to 22 divided by 5.